Alright, Chapter 10, Using Equations. Mastering Solidworks. Parametric sketch relationships are not always drive dimensions with intelligence. You can use equations and variables. Equations help you create simple, complex mathematical relations between dimensions. Global variables can be used in equations just as other dimension names can. In this chapter, you will learn to use equations to create relations between dimensions, link dimensions together, assign global variables, enter expressions, control suppression, states of features and components, linking to existing equations from SolidWorks models, understanding equations as the logarithm sign. You can gain access to the equations dialog by using the toolbar by choosing tools equations from the menu. Equations are stored in a folder at the top of the feature manager. Figure 10.1 shows the equation interface. Using equation interface, you can express individual equations temporarily by deselecting active checkbox to the left of the equation. Equations can also be deactivated with a design table. I discussed the design tables more in detail in chapter 11, working with part configurations, where I also discuss configurations. Caution, although I do not cover configurations until chapter 11, I mentioned part of the relationship between equation configurations here. Equation configurations, are particularly those driven by design tables, should you probably not be mixed. This is not because they do not work together, it's more for the sake of the organization. Adding to this fact, global variables configurable, and it certainly opens with a new possibility, but also creates potential problems for users because they can control the dimensions, both configurations and equations. Also, equations in Excel are far more powerful than the comparatively limited equation functionality offered in SolidWorks. Of course, every user has different reasons for working one way or another. I'm just offering a warning about potential source of a conflict. Equations interface shows the equation global variable dimension equation, sketching visible, dimension visible, 1 to 2, filter, video, redo, undo, name, global variables, features, equation, variable, equation, evaluates, and comments. Automatic rebuild, link to external file, angular equation, units, degree, and automatic solve, and those come with OK, cancel, import, expert, and help. Equations interface offers 4 ways to view equations. Equation view of the link lists the global variable, the feature suppressed by the equation, and all the equations in the part assembly. Sketch equation view lists all the equation variables used in the sketch. Dimension lists all the global variables features suppressed by the equation dimension. This part of some of that can be used in the equation. And then lastly, the order from 1 to 2 eyeballs show the order view. The simplest view is the variable of the equation itself, the value of the equation, and any available comments. Creating equations. Let's look at the part with the variable hole pattern. Equations can be used with space holes along the length of the bar. To prepare for this, we need to name some of the dimensions that will be used in this equation. Naming dimensions, not necessary to name every entity within every SolidWorks document, but you should get into the habit of naming important features, factors, and even dimensions. Name dimensions become particularly important when you use the equation configuration design table. Under the most circumstances, you do not use or even see dimension names, but the equation you do. Name dimensions make a huge difference when you recognize the function other than an equation. By simply reading an obvious example, it would be the difference between D3 at and sketch 6 and length at window extrusion sketch. First name means that nothing but the second one is descriptive if you are familiar with this part. To name a dimension, click the dimension, type the new name in the top of the modified box. You can also go to the dimension property manager primary value panel shown in figure 10.2. Type of the name, dimension, name, title, text block. You can use a symbol at in the dimension names because there's usually the delimiter between the name of the dimension feature of the sketch which applies, but be also aware that even though the software appears to allow you to change the name of the sketch feature in the dimension, Property Manager will not accept the change. You cannot change the sketch or feature name from the dimension Property Manager. Renaming the dimension. Alright, so that's got to be done in the modify smart parameters box. Value, dimension, leaders, other style, tolerances, primary value, dimension, text, dual dimension. Other ways to exit the change of the dimension names include configuration table view with equation manager dimension view. Best practice: you keep the dimension for the name as short as possible while still making it unique in description, because of the size of the interface of the often limited work combined with a sketch. Features name and even parts names or even assembly names become difficult to display readable fashion. Also keep in mind the space dimension may be intercepted by Excel, so don't use space for the names when you assign them. Tip, you can show dimension names as part of the actual dimension by using hide and show all type drop down head up view toolbar. Helpful to know with the feature manager filters dimension names which are named dimensions easy to find. Figure 10.3 shows the filter dimension feature for the sketch include the dimension contained with the filter word height. Other filtered words displayed on the tooltips but the dimension names does not. You can use Feature Manager filter to find feature specific names, and the 10.3 with the filter finds the sketch, which is height-ended dimension. Height-ended dimension model view is shown in the illustrative dimension filter does not display the dimension on the model, but clicking the feature found by the filter displays the value. Alright, so we're using 10.3 figure using Filter Manager filter to filter dimension names. Building the equation. When creating an equation, SolidWorks is often a good idea to write it out on paper first to make sure that the concept is correct. Examine the part shown in 10.4 with the relevant dimension have been named and displayed. With the part shown in Figure 10.4 is included with the download material over the chapter the file name Chapter 10 equation solid part number holds called instances here with the driving variable. From the number of spacing holes is calculated over the length of the part. This is also the gap on each end of the pattern holes. This gap is measured between the center of the last hole end of the part. Also needed to be half of the spacing between the holes and sigma symbols. It's given a sigmata symbol to the left of the dimension indicate the equation is driven. Equation is driving it, dimension driven, and the equations cannot be directly edited. So over here is your sigma cells. This on the left dimension indicates equation is driven. 10.4 shows variables for hole patterns. We have two equation dimension driven, the gap and the spacing. Tip, dimension text in general can be difficult to read for short and on 3D display to make the task easier, but they're setting to show all the dimensions on the flat screen. It can be found with tools option display. In this case, more sophisticated equations have not been implemented to account for the diameter holes, possibly interfering with one another where the large number of the holes. In other words, because of the two values that need to be calculated, the space and the gap, you need to create two equations. Because of the gap dimension is always half of the spacing needs to be calculated as follows. Spacing is equal to the number of instances, space is equal to the length over the number of instances minus 1 plus 1. The instant -1 stands for the number of spaces, and if you have two holes, then there is only one spacing. The term 1 stands for two half spacings from the two ends. The second equation is simpler and looks like this. Gap is equal to spacing over 2. Order the equations. If it's important, SolidWorks equation interface figures out whether it's necessary to order the equations, put them in order. Because of the gap is dependent on the spacing, spacing must be calculated before the gap. SolidWorks also automatically figures out whether the equation needs to be solved multiple times in order to stabilize it. Figure 10.5 shows the resulting set of equations over the equation interface for the time being shown in the order view as opposed to the equation view in Figure 10.1. So we're back to the equation global dimension, global variable dimensions, and we're on the sigmata equations, hole pattern, globe variable equations. We've got space pattern 1, gap sketch, valuable. And then, so the spacing was given a length at sketch over the instances at pattern 86 ounce of an inch. Spacing is equal to the L pattern 1/2. And before building the equation, you should first display the dimensions you need to create the equation. You can add the dimension equation clicking them from the graphic view window. To do this, right click on the annotation folder at the top of the feature manager. Select the feature dimension. You should select the display annotation heads up view toolbar, hide show all types view component and the annotations option if not already selected and shown in Figure 10.6. When you have done this, all the dimensions you need to create every picture is displayed. Also be sure to turn the show dimension names option. You'll find it in the heads up view toolbar. Figure 10.6 shows all the dimensions in this part. Show the view component annotations. With the view sketch, the dimensions should always be on. View dimension names is in D1, and then the view to sketch dimensions and view annotation with the ABC assemble apart, not the assembly. For models that have more than few features, show all the dimension of the entire model may overload with the screen information. In this case, you double-click the feature with the feature manager to show all the dimensions on that feature. To build the equation, go to Tools, Equations. Alternatively, you can click Equations on the toolbar and right-click with the equation folder with the feature manager. Select Manage Equation. Make sure you have Ordered Equations View activated with the upper left corner of the Sigma Equation View, the dimension of the dimension view, and 1, 2, 3 Ordered View. Next, click the Add Equation box at the bottom of the list. Then click the dimension that you want to draw. The Solidworks adds the name of the dimension and automatically switches focus in the value of the equation column where you enter the value of the equation. Clicking the drive of the dimension shown with the view that is needed. Type as needed, selecting from the list of functions and properties. You can also measure the right here with the equation dialog box. Any measurement you make, save the reference dimension, enter it into the equation. So as such, when you have a valid equation, SolidWorks fills out, evaluates through the column for you. Notice all this also that if your equation is valid, green check appears in the box. If not, the syntax that makes it is invalid, displayed in red. This check mark is shown in gray. Using comments. Notice that the comment right with evaluates of the column figure 10.5. Comments can be very useful annotation equations for yourself and others. Two important reasons for the annotate the error. Remember the significance of the variable dimension to add special notes about the logic of the equation that may not be obvious. Tip, you can make general comments with the model of the design journal Microsoft Word document that is embedded within the SolidWorks file. Design journal is found with the design binder folder near the top of the feature manager. Using driven dimension, sometimes it's necessary to use the driven or reference dimension. In this equation, reference dimension is displayed in gray. This is particularly true with the best way to calculate the number and to use existing 3D geometry. For example, the manufacturing helical auger in a 90-degree section from a flat steel stock. You need to design an auger 3D, but being manufacture it in 2D. What is the shape of the auger when flat? The best way to figure this out aside of the loft that has been discussed in Chapter 34 using SolidWorks sheet metal tools is to use little on a high school geometry construction sketch and use simple equations. Figure 10.7 shows the 90-degree section of the auger blade, the outside diameter 12 inches of the blade with width of 3 inches of the part shown in Figure 10.7, and include the download material of the chapter file named Chapter 10 Auger Solid Part. Overall height is 4 inches. In this case, auger is represented with the surface because the thickness is ignored. Surface feature can be useful in situations like this using construction geometry and or discussed in Chapter 32 working with surfaces. Okay, so this is represented the auger. With the information you collect, the length of the 3D edge of the sketch of the simple equation, figure 10.8, hypotenuse of the triangle represents the helical edges of the inside outside auger, making part of the triangle same height with the auger section, making the horizontal side of the triangle same length with the quarter of the inside and outside diameter. By using simple equation geometry sketch relation, automatically calculate the flat lengths of the inside outside auger, and that would be length of the triangle side is equal to the diameter of the circle times pi divided by 4. In this way, the triangle is used to simply calculation to give that view result. Triangle is calculated length of the helical. So as you have this triangle, that triangle, this triangle. We've done 10 by 4, 6 by 8 in the green, and then the rest are given a gray shade with the sigma equations 942, and then another bend at 471. For this point, you calculate the flat pattern again using the SolidWorks sketch, solving the capabilities of the calculator. Think of the auger as being a cardboard tube installed with a roller-powered roll of paper towels. If you examine one of the tubes and closely, you will see that it's simply a straight and a flat strip of cardboard that has been wrapped around a cylinder. What was the flat straight edge of the original board is wound in a helix. The method is simply a reverse process. For example, it requires lift to be used. Arc length dimension drives the size of the arc. The hypotenuse dimensions are shown with the driven dimension reference dimension that are used to drive the arc length dimension is shown in Figure 10.9. Remember that you can create the arc length dimensions by a smart dimension tool. Click both endpoints of the arc and the arc itself. The reason behind this example may be a little difficult to grasp, but the equations in two sketches can be simple. Caution: using reference dimensions of the driving independent or right side of the equation can, in some situations, require more than one rebuild to arrive at the stable value, meaning the value does not change within the next rebuild. SolidWorks detects this and can adjust it for you. Alright, so now we're figuring the flat pattern of the auger. We've done this equation of the arc 1 and arc 2. Use the equation trick. Solidworks equations all several mathematical operators such as sin, cosine, tangent, and other. Solidworks also if statements considered operator is equal, less than, greater than or equal to, greater than, less than, equal to, in the file properties. Using if statements. The word is how an if statement is used. If some of the relationships are filled with the if function returns a value, with the relationship is not filled with the returns a different value. More technical description, if the expression value is true, but the value is false. If the practice you could use like this, if an x is greater than 5 or x is minus 1 or x plus 1, which reads, if x is greater than 5, then subtract 1 from x. If not, then add 1 to x. One of the reasons considered a parlor trick with a function causes the value of x to oscillate between the two numbers, depending on the number that it starts with. Each rebuild with the SolidWorks identified circular reference becomes the same value for both sides of this equation. It may be difficult to imagine an application with sort of the behavior would be desirable, but you would combine it to a macro, simple to rebuild with a model of the number of the times you can use to create an animation effect. Figure 1010 shows the equation using an if function. Alright, so we've now been in the equation global variable filters, and if equation was put at the hole, the length at base is less than 3, suppress, and then suppress or unsuppressed. Evaluates to unsuppressed. You can use the if statement with a visual basic application function to control the suppression state features and components. Functions desired detail later in this chapter. Using global variables. A global variable supersedes the pre-2012 link value. This is just named a sign with a depression reference measure for the entire equation. Link values are still extremely powerful tools. The fastest way to link multiple dimensions in bulk is using a link value. Global values are assigned an equation dialog box modified dimension, simply variable name equaling an expression or value. Figure 1011 shows the list of the equation global variables with the type of the variable name. Do not need to add a quotation mark. They are added automatically with the global variable needs a multiplier using expression calculate its value. Global variable shown in figure 1011 called the global variable is simply assigned and valued directly. So you have your global multiplier variables, and we're given their values, what it evaluates to it. Custom and fill property drive in the equations. Right click on the equation folder, select the show file properties. You will see what the default file properties already exist and list and show in figure 1012. If you right click the equation, it will show file properties, and the default properties are exist and list and show in figure 1012. So you have these ones. An equation editor shown in figure 1012 expands the list of function custom properties, easy selection, placement into equations. Any custom properties you add or the type of the number automatically added to the list can be used with the equation. Note that you assign both a custom property and global variable with the same name. The global variable takes precedence over the custom property when available to evaluating an equation. Global variables configured in Chapter 11. Working with the part configuration covers the feature of the more detailed syntax for using design table to drive global variable as follows. The value is the stamp value at global variable name at equations using modifying box. Modified dimension box can accept the equations. You can either create an on-fly global variable to start the equation modified box. First replace with the numerical value with an equal sign in the value box. When you do this, you will see a drop-down function file properties as shown in figure 1013. You can also change the name of the dimension right here to add other dimensions to the equation. Just click them. Alright, 1013 starting equation modified box. We've gone to modify this dimension. And we've gone to functions and the modified box of the equation, and now we've gotten kin, cosine, cotangent. All the cosine tangents are and cotangent, exponential, log, square, signal, and if. If you key a numerical value, SolidWorks drop down list of the possible units possibility operators. If you do not have anything Then the document unit setting is used. Additional, you can use the dimension entirety box separate property manager windows the same way shown in figure 1014. 1014 using property manager dimension in the entry box to the conclusion. So we're now working on the base from sketch plane direction, and then the dimension we've used a function, and it shows the function equations on the side and the direction we want to, and select the contour. Using expression can also be entered directly in the dimension dialog box, modify dialog box, property manager value box. Expression must be composed of numbers, mathematical operators, and expressions such as 2.375 plus 4 divided by 8 divided by 3 minus 1.1 is perfectly acceptable as 1 plus 1 divided by 2. Or 1 1/2. In this second case of the example, the plus symbol is understood. Other types of operations are available, such as one changing unit dimension box. For example, if you're editing parts in inches and enter 40 millimeters, Solidworks performs conversion for you. You can even mix the using unit single expressions such as 4.875 plus 3.5 millimeters, where an inch part is assumed as document units. Using equation, Solidworks does not remember the expression itself, only a final value. The difference between expression and equation presence of the dimension, variable names, and corrections can be entered into any place where the dimension for the Solidworks feature. Alright, controlling suppression and state features. If you can use an if statement to describe earlier chapters to control suppression state of the feature components. As an example, of syntax would be feature name if equal to expression value is true and value if false. Figure 1015 shows the type of the equation used. In this case, the feature area of the middle of the chart, so equation value of the figure. To get the figure into the cell, make sure the cell is selected. Click the feature manager of the graphic windows, and anything that quotes can be selected if you do not have to worry about the spelling or syntax. If the is statement reading in the English, if the spacing is greater than a half, do not suppress. If not, then do suppress. There's a little double negative thing going on there, but if the suppression table does not the existence of the feature itself, that are you controlling. So it's 1015 shows the using if control suppression. You can use the equation assembly with the control suppression states and components and parts and subassemblies. Linking to external equations. Alright, linking to external equations. You can use external save the equation, share the equation between models, export with the equation, and clicking on the export button on the right side of the equation dialog box shown with the figure 1015 link with the current model external save the equation, making sure that the link external file option is checked at the bottom left of the equation export dial as shown in figure 1016. So we've now gone to save an equation an external file. It's now saved as an external equation, and you save that. Equations are saved in text file. Default name of these external equation text is equation text. You can change the name if you'd like to remember it. If you use the window explorer, change the name or change the reference file. Closed Solidworks will not know the file name has been changed. The bottom of the equation dialog box is part of the linked equation file. You can link to only one equation file at a time. To link existing equation Solidworks model, use the import buttons. Equation dialog. Also be aware that only equation and global variables can be shared in this way. Alright, tip. Having the equations in multiple parts links the external text file. Nice technique of creating families or parts without need of the assembly configuration table. Alright, tutorial using equation. Get some practice writing equations following these steps. Start with the part with the file number chapter 10 tutorial. Start solid part and download material shown in figure 1017. So if you did go to the Wiley website for this bike, you can download these. But starting on the equation tutorial, you've done the direction spacing 360 degrees, instances of 4. Show the dimension names heads of the view toolbar to find the setting. Double click circular pattern feature for the display of the angle number to instant of the feet related to the features. May have to move the angular dimension to see the pattern of the instant number. Click with the instant number chain with the name of the dimension to a pound or a number sign and the dimension with the property manager to make sure that the instant 3D option is selected when you do this. Double click this feature with the feature manager, which is revolve and rename the 3.6 and 3.6 inches dimension cap rad. Again, selecting it using property manager, write the equation, draw the number of legs and cap rad divided by 7. Open the equation dialog box, choose from the tools equation, click add the equation, double click the circular pattern, click over the number of the dimension, or the number sign of the dimension, to make sure of the name of the dimension listed in the equation box, type the equal sign, double click revolve feature, click over the cap red dimension, then type type divided by 1/2, then add the common equation identified with the driven dimension. 7. Click rebuild, control B or control Q to rebuild the model. Observe whether any of the updates take place. Replace the 6-inch dimension the height of the revolve feature for the dome height. Create a second equation, drive the dome height dimension of the current ratio of the height to the radius. In the equation dialog box, create a global variable called the ratio of 6.6 over 3.6. Which is 1 2/3. Create the equation. Equation takes the form of the dome height equals the ratio cap radius. You can use the drop down list for the under the calculator part to select the ratio variable from the list. Use a variable to make the radii fillet 1, fillet 2, and the same. 11. Double click with the revolve feature, change with the cap red to dimension 5. The rebuild, you should observe with the 3 feet. Change it again 6. You should see with the 4 feet. Give the part with the name, including with the initial with the date, and save the closing. See figure 1018. Alright, now 10, figure 10.8 in the finished part. Bottom line, SolidWorks equation related with the dimension management tools of the powerful last several releases for have been vastly updated. Even if you've been a huge equation user, the ability to build equation modified with the Project Manager dimension box is a great convenience for such powerful function. Be careful about crossing SolidWorks native equation functionality with configurations. You may end up with a dimension for the control of both tools. Remember, the calculation capability excels far greater than what is found in SolidWorks equation. Mastered equations and variables are key to parametric design. Start simple by creating rectangle with size made equal using variable name or vertical horizontal dimensions. Master, if you've created a rectangular sketch with equal size, make sure the extrusion depth is equal. No matter what size or solid, will always be a cube. Mastering one of the most common situation designs needing to spread out over the holes. Equations are a great way to do this. Study the part of the name. Chapter 10 equation solid part and recreate it on your own. Chapter 11 working with part configurations.